Hello friends, welcome to HP Event Academy. In the last lecture we have discussed up to question number 4. So we will discuss question number 5 onwards in this particular lecture. So let's start our discussion. So what is given in question number 5? So we have a heavy circular ring of weight W is free to slide on a smooth circular wire of radius A. So let us draw a smooth circular wire. So we have a smooth circular wire like this. Okay. And we have a heavy circular ring of weight W that is sliding on this circular wire. Okay. Circular wire of radius A fixed in a vertical plane. So this is fixed in a vertical plane. It is attached to a string of length L. Okay, so length is bounded by 2a and a root 2. So this distance is, the diameter is 2a, this is 2a, and we have a root 2. So a root 2 will be this is a root 2. Okay, and this length is 2a. Okay, so we have, it is attached to a string of length L. Okay, so L varies from 2a to a root 2. Okay, so this means this string will slide from this particular position to this particular position. Okay, so let us consider a point P here. Okay, so let us consider the position of the string at an angle of theta. Okay, so at an angle of theta we have considered the position of a string. So this distance is 2a. Okay, and this is the string of length L. Okay, so this string of length L varies from 2a to a root 2. Okay, so we have considered the position P at an angle of theta. Okay, so now let us consider, so this is theta. Okay, so let us join this. Okay, so this value is a, this is radius, this is radius. Okay, so this is theta. So since these two are equal, because this is radius, let us consider this point as O. So this is theta, so this is also theta. So this will be 2 theta, and this is a ring. The weight of the ring is W. So this is capital W. Capital W is the weight of the ring. Okay, so now let us consider R be the reaction. Reaction on this string will be along the radius. Okay, so this is our reaction. Okay, so this angle is theta and this is 2 theta. So this will be, so this is 90 degree. Okay, so let us consider this as alpha. So alpha plus 2 theta is equal to 90 degree, that is pi by 2. So alpha is equal to pi by 2 minus 2 theta. So this angle alpha is pi by 2 minus 2 theta. Okay, and this angle, what is this angle? So this whole angle is pi. So this will be pi minus theta. Okay, now let us find this one, this angle. Okay, so this angle will be, this whole angle is pi. So this angle will be pi minus pi by 2 minus 2 theta. So this is pi by 2 plus 2 theta. Okay, this whole angle, let us draw this again. This whole angle is pi, and this angle is pi by 2 minus 2 theta. So this angle will be pi minus pi by 2 minus 2 theta. So this is equal to pi by 2, pi minus pi by 2 plus 2 theta. So this is pi by 2 minus 2 theta. Okay, and this angle will be this whole angle. So this angle is pi by 2 minus 2 theta plus theta. So pi by 2 minus theta. So this is pi by 2 minus theta. Pi by 2 minus theta. Okay, so we have, let us analyze the point P. So we have the reaction R here, and this is our string. So let us consider the tension in the string is T. So we have the tension in the string as T, and we have the weight as capital W. Okay, so let us find these angles. This angle is angle between R and W. Angle between R and W is pi by 2 plus 2 theta. So this is pi by 2 plus 2 theta. And we have the angle between R and T. So R and T is pi minus theta. An angle between T and W. So T and W is this one, pi by 2 minus theta, pi by 2 minus theta. Okay, so now let us apply the Lami's theorem. Okay, so let us apply the Lami's theorem on this particular figure. Okay, so we have this one, W upon sine of pi minus theta. So W upon sine of pi minus theta is equal to W upon sine of pi minus theta, W upon angle between T and R. Okay, let us write down one step one step more. Okay, so we have the force upon opposite angle. So we have, let us take force as W. So W upon opposite angle is this one, sine of angle between T and R. Okay, angle between T and R. This is W upon. Now we have R upon sine of angle between T and W. Angle between T and W is equal to T upon opposite angle between R and W, sine of R and W. Okay, so let us write down. So we have W upon angle between T and R, W upon T and R, that is pi minus theta. So sine of pi minus theta is equal to R upon sine of angle between T and W, R of angle between T and W, sine of pi by 2 minus theta, sine of pi by 2 minus theta is equal to, we have T upon angle between R and W, that is sine of pi by 2 plus theta, sine of pi by 2 plus 2 theta. Okay, so this is equal to W upon sine theta is equal to R upon cos theta is equal to T upon cos 2 theta. Okay, so we have to find the value of, so that the tension in the string. So T is equal to, from this particular expression and this particular expression, let us equate this. So T is equal to W times of cos 2 theta upon sine theta. Okay, so this is equal to W times of 2 cos square theta minus 1 upon cos 2 theta is cos 2 cos square theta minus 1 upon, and sine theta we can write as 1 minus cos square theta under root. Okay, so now let us go back to this one. So we have the length of the string as L. Okay, and we have this as center. Okay, so we have the radius like this. Okay, so this angle is theta and this angle is theta. Let us draw perpendicular from here. Okay, this is radius, the radius is A and this is radius. Okay, so this length will be A times of cos theta, A cos theta, and this length will be A times of cos theta. The whole length will be 2A cos theta, and this is equal to L. So from here cos theta is equal to L upon 2A. So let us place cos theta is equal to L upon 2A. So T is equal to W times of 2 times of cos theta is L upon 2A. So this is L square upon 4A square minus 1 upon root under 1 minus L square upon 4A square. So this is equal to, this gets cancelled to 2A square. So we have W times of L square minus 2A square. Okay, L square minus 2A square upon 2A square into, this is 4A square minus L square, and this is equal to 2A. Okay, so under root of 4A square is 2A. So this gets cancelled with A. So we have tension is equal to W times of L square minus 2A square upon A times of root under 4A square minus L square. Okay, so this is the value of the tension. Okay, as given in the question. Okay, so let us discuss question number 6. Okay, so what is given in question number 6? Three equal strings of no appreciable weight are knotted together to form a equilateral triangle, and the weight W is suspended from A. Okay, if the triangle is supported with BC horizontal by means of two strings at B and C making an angle 3 pi by 4 with the horizontal, show that the tension in the string BC is given by this particular expression. So let us solve this. So we have three equal strings. So let us draw this. Three equal strings of no appreciable weight, and the triangle is ABC. Let us consider this point as A, this as B, and this as C, ABC. Okay, and there is a, and weight W is suspended from A. There is a weight W. If the triangle is supported with BC horizontal, this is BC, by means of two strings at B and C. So there are two strings at B and C. There are two strings at B and C making an angle 3 pi by 4. Okay, so this is our horizontal. Two strings at B and C. This is making an angle 3 pi by 4. This is also 3 pi by 4. Okay, and it is a equilateral triangle. So this is 60 degree. This is 60 degree. And this is also 60 degree. Okay, and in terms of angle, it is 135 degree. This is also 135 degree. 3 pi by 4 is 35 degree. 3 pi by 4 is angle in terms of radian. Okay, so this is 135, this is 60. So this angle will be 360 minus 135 plus 60. So this is 360 minus 195. Okay, so this is 165 degree. This is 165 degree. Okay. Okay. Now let us consider the tension in this string as this is T1 and this is T2. So since it is symmetrical, this is also T2. And let us consider the strings at these two locations as T3. Okay. Let us go back to the question. So we have three equal strings of no appreciable weight are knotted together to form an equilateral triangle. This is equilateral triangle. This is A, this is B, and this is C. Okay. If the triangle is supported with BC horizontal by means of two strings at B and C. So there are two strings at B and C. Two strings at B and C. These are the two strings, and we have considered the tension in these strings at T3. Okay. And the strings are making an angle 3 pi by 4, that is 135 degree they are making with the horizontal. Okay, so this we have found as this is 135, this is already 60 because it is an equilateral triangle. So this angle will be 360 minus 135 plus 60, that is 165. Okay, so this is also 165. Okay, so now let us consider this point A. So at point A we have the weight capital W. Okay, and we have the tension as T2 and this is T2. So this whole angle is 60 degrees, so half of the angle is 30 degree. Okay, so we have, let us resolve this vertically. So 2T2 cos 30 is equal to capital W. So 2T2 into cos 30 is root 3 by 2 is equal to capital W. So we have T2 is equal to W upon root 3. Okay, so the value of T2 is W upon root 3. Okay, so now let us consider the point B. Let us apply the Lami's theorem as at point B. Let us apply the Lami's theorem at point B. So at point B we have this as horizontal. Horizontally we have tension as T1, we have tension as T2. Okay, tension in the string AB. This is tension in the string BC. Okay, and we have the tension as T3. Okay, so this angle is 135 degree. This angle is 165 degree and this angle is 60 degree. Let us apply the Lami's theorem at point B. Applying Lami's theorem at point B. Okay, so we have T1 upon sine of 165 degree is equal to T2 upon sine of 135 degree is equal to T3 upon sine of 60 degree. Okay, so we have to find the tension in the, so that the tension in the string BC, so the tension in the string BC is T1. So we have to find T1. So T1 is equal to T2 times of sine 165 upon sine of 135. So this is equal to T2. The value of T2 is W upon root 3. So W upon root 3 times of sine 165 we can write as sine of 180 minus 15 degree. And this is sine 135. This is 180 minus 45 degree. Okay, so we have T1 is equal to W upon root 3 times of sine of pi minus theta is sine theta. So sine 15 degree. Sine 15 we can write as sine 45 minus 30 upon sine 180 minus 45. This is sine 45. And sine 45 minus 30. So this we can write as sine A minus B. Sine of A minus B is sine A cos B minus cos A sin B minus cos A sin B. So this is equal to, let us consider this as sine of 45 minus 30. Okay, so this is equal to sine 45 cos of 30 minus cos of 45 times of cos of sine of 30. So this is equal to 1 upon root 2 into root 3 upon 2 minus 1 by root 2 into 1 by 2. So this is equal to root 3 minus 1 upon 2 root 2. This is sine 15 degree. Okay, so let us place the value here. So this is equal to W upon root 3 times of, this value is root 3 minus 1 upon 2 root 2. Okay, and sine 45 by 1 root 2. This is 1 upon divided by 1 upon root 2. Okay, so this will be this will go in top. This is root 2. So root 2 gets cancelled and this is equal to, so T1 is equal to, this is equal to W times of root 3 minus 1 upon 2 root 2. Let us multiply by root 3 from top and bottom at top and bottom. So T1 is equal to W times of root 3 minus 1 upon 2 root 2 times of root 3 at numerator and root 3 at denominator. So this is equal to W times of 3 minus root 3 upon sorry, this is root 3 minus 1 upon 2 times of root 3 है ना, 2 times of root 3. Okay, so this is equal to W times of this root 3 we have multiplied with root 3. So this is root 3 times of root 3. This is 3 and 1 times of root 3. So this is root 3. Now we have 2 times of, this is root 3 and root 3. This is 3. So T1 is equal to W times of 2 minus root 3 upon 6. Okay, so this we have to show into, sorry, this is 3 यार गलत कर दिया सर. So this is equal to W times of root 3 into sine of 50, that is sine of A minus B, that is sine of 45 minus 30. So this is equal, this value is equal to root 3 minus 1 upon 2 root 2. Okay, and we have sine 45 degree, that is 1 upon root 2. So this is root 2. So this gets cancelled. So we have T1 is equal to W times of root 3 minus 1 upon 2 root 2. 2 root 3. This is 2 and this is root 3. So this is 2 root 3. Let us multiply root 3 in numerator and denominator. So this is equal to W times of root 3 times of root 3. This is 3 minus root 3 upon, this is 2 times of root 3 and root 3 is 3 and 3 times of 2 is 6. So this is 6. So W times of 3 minus root 3 upon 6 is the tension, and T1 is the string, is the tension in the string BC. Tension in string BC. Okay, so this we have to show in question. So we have to show in the question that show that tension in the string is given by this particular expression. Okay, so we have discussed up to question number 6. So we will discuss further questions in next particular lecture. Thank you.